Good evening, everyone. Welcome to this session about the biomechanical design track within the mechanical engineering master. My name is Bob van Vliet. I'm the coordinator for this master track, and I'll do my best today to present the track, what it's about, how it's structured, and give you enough information to make an informed choice about whether you might want to come study in our track. I have some assistants who will handle the live event Q&A. So Eva, a student in our faculty, will answer any questions that you might have. And of course, after my presentation, I will have also time to answer any questions that might be left or that Eva wasn't able to answer. Okay, to start off, what is biomechanical design about? Well, we like to say that biomechanical design is a special track within the mechanical engineering master because you don't just learn about a field of technology, but you also learn a little bit about yourself, or actually quite a bit about yourself, about how human bodies work in terms of mechanisms, actuation and control systems. You also learn about other biological systems. So in that sense, it's quite a special and different track within the ME master. And why is that important? Why is that relevant? Well, that knowledge allows us to design systems that interact with biological systems. Lots of robots and other mechanical technologies are moving into homes, public spaces. We have self-driving cars. So people are interacting with mechanical systems more and more. That needs to be safe. There needs to be a little give and take, and it helps when you understand how humans work when you design that. The other side of that coin is that a lot of the things we learn about biological systems, it turns out those mechanisms and material properties we can often use to make our technological systems perform better. So those are the two things why this is a relevant and interesting topic, because we need to design more and more systems that interact with people and with other biological systems. We like to learn from biology to make our stuff better. So what will I be discussing in this presentation? Of course, I'll show you the curriculum, what's the content, which courses might you take, how is it structured, and what's it about. I'll discuss the difference between our track and two different master programs, biomedical engineering and robotics. There's often questions about what's the difference and why should I pick one and not the other, and aren't they almost the same? I'll discuss what makes us unique and what their characteristics are. I'll talk a little bit about what you need to do and have done to get in, bridging programs, and of course a little bit about where you might end up after studying biomechanical design. And I'll start with the curriculum, and I have to start with a remark about that, namely that it's under construction. We're making a new curriculum for the coming September. It's not a complete redesign, but we're tweaking it a little bit. So what I'll present today is different from what's in the brochure that you can download. What I'll present today is actually the new curriculum. So what I'll show you is the truth, and we'll update the brochure shortly. And it hasn't been updated yet because we've just decided on this new curriculum. So this is all very recent. But let's move on to the curriculum. This is what it looked like. We're going to zoom in on it in a bit. But like I said, this is the new one. It looks a little bit about like the table in the brochure, but don't be fooled, it's different. So we're going to zoom in on it. And I'll walk you through it. So what do you see here? Well, first of all, this is only the first year. We'll get to the second year. But in your first year, you start, or the first part is a set of courses that are obligatory for the whole mechanical engineering master. Biomechanical engineering is a track within the mechanical engineering master, so there's a few obligatory courses that all mechanical engineers take, and you must take as well. This also includes an ethics or a social course, and you can pick from a list for that. So in addition to that, there's of course a few obligatory courses specifically for BMD. And these are about, well, two topics mainly, about biomechanics, of course, but also about control systems design, because that is also an important part of biomechanical design, to understand and to deal with biological systems as control systems. So you learn about control systems, you learn about biomechanics, and the third core topic of our master is mechanical design. So in addition to these courses, you're also obligated to choose two, you can choose more, but at least two design project courses. So everybody who chooses biomechanical design will do a few real creative mechanical design projects. And there's a list of available courses that have design projects, and you can pick the ones that interest you most. And then in addition, there are of course electives. And this part is not obligatory at all. The parts at the top of this table are the obligatory parts, and then about half of your study points are free to choose electives. But instead of just saying pick anything, we have a few recommendations. If you want to specialize, for instance, in robotics, there's a set of courses that make sense together. If you want to specialize on the biomedical side of engineering, there's a set of courses that make sense there. You can also tweak BMD to be a more general and broad mechanical engineering master, and then you can focus on a few more mechanical engineering topics. So we have a set of recommended courses that go well together, but you can mix and match these, and you can pick your own curriculum as long as you choose something that makes sense as a whole. So that is the first year. And then after that, of course, you get the second year, and the second year is projects. So the first part of the second year is mostly an internship. You can also apply for the joint interdisciplinary project. That is a course that is interdisciplinary with multiple faculties, and you do a project in a student team, but you need to be admitted to that. So it's not sure that you can do that. You can also do extra electives, so pick 15 points of a coherent set of extra electives to specialize in something. But we recommend, and most our students do, an internship in a company somewhere outside the university, sometimes also in a research institute or in a hospital. But we like to send our students outside for 1 quarter of their master. But you do that under the supervision of one of our researchers. And then the second part of your second year, or actually 3/4 of your second year, is your graduation project, which is a literature study coupled with a thesis project. And most of our students do their graduation project under the supervision of a researcher at our faculty in our department. So most graduation projects are tightly coupled to the research in biomechanical engineering that is going on right now. Okay, so that is the curriculum as it stands. I'll put it back for a bit. There's a first year with some obligatory courses and elective courses, and a second year with projects. All of these courses are in the study guide. The curriculum is new, but the courses all exist already. So I'll give you a link to the study guide in a minute. So if you, after this presentation, you're curious about 1 or 2 of these courses, you can look them up and read in detail what they're about, and what form they have, and what the study goals are, and so on and so forth. So what I want to do now is show you some images of projects that you might encounter during these courses. So what the topics are that are treated within these courses, and also topics that might be something that you graduate in. So one of the areas you might specialize in is the side of biorobotics, or augmenting human motor systems. For instance, this is a backpack with gyroscopes that prevents falling, so it counteracts the falling motion of the person who's wearing it, to prevent falls in the elderly or people who are somehow disabled. So this is a very complex mechanical system that also requires knowledge of control systems to make function. So this is a good example of a highly mechanical design project but you do see the link with understanding how humans move, how they walk, how falling works, and so on. A different project in this research group is this system. It's called the Ryzen system, and that's a system that is mounted in a room, and it's used for biomechanical research. It can support the subject, and it can exert a force on them, so it can try to make them fall and see how they react. But it can also support weaker people during their rehabilitation, for instance. So if you pick this direction, what will you learn? Well, if you pick this direction, if you pick courses in this topic, you'll gain lots of experience with simulating and designing robots and their control systems. You'll dive very deeply into modeling the human body as a control system. So how are our movements actuated? How does our nervous system interact with all the actuators and musculoskeletal system? Applications are wearable robotics, rehabilitation robotics, but also human factors, for instance, in the area of self-driving cars and those sorts of systems. And some of the courses you see in the list here are also the courses, of course, you saw in the curriculum a few slides back. Quite a different area where you might specialize is in bio-inspired technology. For instance, what you see here is an instrument for laparoscopic surgery that is based on how squid tentacles and elephant trunks work. So it's a system of cables inside that means that you can make these very complex steering motions. And as you can see, this is quite a delicate mechanical object. So even though the application here is medical, it's a surgical tool. The research line that this is connected to is quite broad, and it's very focused on small mechanical systems. This is a lot smaller scale than the systems you saw in the robotics projects. You can see in the image on the left with the eye, these instruments can become really, really tiny and still have that steerable functionality. And again, this is based on biological systems. A different example project in this area, there's an ongoing line of research in prosthetics, not just hands and not just 3D printed hands, but you can imagine all sorts of prosthetics and the systems that go with that. And a good example, a good recent example of what the people in our department are able to do is last year when the COVID crisis struck and it appeared that there was going to be a shortage of ventilators. The knowledge of the human body coupled with mechanical design skills means that from our department, 3 different ventilator projects were started. And the image you see here is of a completely mechanical solution based on a museum piece. This is actually the only one of those projects that actually went into use in Latin America. So this is a highly mechanical design, a mechanical system with a medical application. And again, this area, bio-inspired technology and the development of medical instruments, is a highly mechanical design focused specialization. So we also have loads of researchers optimizing almost every part of surgical instruments, for instance. So if you really like designing smart mechanisms, this might be the track for you. So what would you learn if you pick this specialization or courses around this specialization? Here you would learn a lot more about nature's mechanical systems, not just ours, human systems, but also materials and mechanisms in plants and in other animals. You'll learn design methods to translate that into technological solutions. And also you might dive into compliant mechanisms, for instance, and other mechanisms that work well with our squishy human bodies and can distribute forces equally and make things very safe and comfortable to use. And courses include bio-inspired design, which is a design project course. You might specialize it and look a bit more into physiology. Biomechatronics is a course that deals with prosthesis design and also robotics. And again, you might take a 3D printing course and go in that direction. There's loads of courses that would prepare you for a project in this area. And you might be thinking, is everything medical? If I pick this track, can I only design things for in the hospital? The answer is no. I'll get to that when I talk about the difference with us and biomedical engineering, for instance. But a different example is also these sorts of projects. We have an entire lab called the Bicycle Lab, and they also do lots of sports engineering. So they help bicycle racing teams optimize their strategies. They design self-driving bicycles or drive-by-wire bicycles. There's lots of projects where they instrument sport equipment like rowboats or skates to really investigate the biomechanics of those healthy people doing extraordinary things, to learn from it, to support it, to help us win the Olympics. But in the case of bicycles also to make, for instance, these very powerful modern electrical bicycles safer to use. So no, not everything is medical. So that was what I wanted to say about the curriculum, the courses, and the topics that you might encounter. And again, I'll give you a link to where you can find more information about the specific courses that I mentioned. But first I want to go into this question of what is the difference between biomechanical design and two other masters that are popular and often an alternative for this one. So, we've been talking about biomechanical design, a track within the mechanical engineering master. A different program that is often compared with that is biomedical engineering. So what is the difference? Well, one of the main differences is already in the name. Biomedical engineering really is about medical technologies. As I said, biomechanical design often deals with the human as a healthy system. We also study other things than humans. We study plants, other animals. Biomedical engineering does not do that. Plus, BMD is a track within the mechanical engineering master. So we go way more in depth in the mechanical design of things, which in biomedical engineering is not necessarily required or possible. So biomedical engineering really focuses on treatments, on hospital applications, and it's a lot less about mechanical design of systems. A new program that is these days also often an alternative for BMD is robotics, because I also discussed things within our master track that fall under the header of biorobotics, for instance. So we also do a little bit of robotics. So what then is the difference with the master about robotics? Well, the thing there to realize is that the department that organizes that master is called cognitive robotics, and that is reflected in the curriculum. The robotics master is a lot about the programming, perception, intelligent behavior, and the control of robots, while biomechanical design within mechanical engineering is also about the mechanical design of those robotical systems. And that is something they focus on a lot less in the robotics master. That's really about the control and the behavior of robots. We are also, or mainly, about the design of the mechanical systems within those robots. So those are the main differences. And the one thing that both these answers have in common, the difference with BME and with robotics, is again, BMD is a track within the mechanical engineering master, so you also become a mechanical engineer. When you do one of those other masters, you'll become either a biomedical engineer, that will be on your diploma, or a robotics engineer will be on your diploma. But if you choose BMD, your diploma will say mechanical engineer and the track biomechanical design. So there are more courses about the in-depth mechanical engineering of physical systems, and also a lot more about methods and skills to design those systems. So it's not called biomechanical design for nothing. That really is one of the core topics of our track. Okay, that about the difference between us and those two other masters. I imagine there might be still some questions about that. I'm seeing all kinds of things pop up in the live chat, but I'll look at that after my presentation. First, I want to say a little bit about admission and bridging. In the list of people attending today, I saw a lot of people from Dutch HBO institutions and also a lot of people from abroad. So I cannot give you a detailed description of all the admission requirements and all the bridging requirements for our master. What I'll do is I'll refer you mostly to our study guide, which is online, studiegids.thudelft.nl. All our courses are there, so also all the other course names that I showed, you can look them up in the studiegids. In the studiegids, we also have all our bridging programs. So when you go to program in that system, you can select bridging programs for 3ME, and all the bridging programs both for the HBO to us and also for every bachelor in Delft that it's possible to bridge from to us. The programs are there, so you can see how many EC must I do, which courses are those, how long will it take. So all the bridging programs are in the study guide, so you can look them up. And if you have particular questions about bridging, please ask them to the bridging coordinator, because biomechanical design is a track within the mechanical engineering master, bridging is the same to all mechanical engineering tracks. What we require is the same level as our mechanical engineering bachelor students. And that goes for all the tracks within mechanical engineering. So there is one coordinator for all the bridging to mechanical engineering, and you can reach them via this email address. So usually when you ask me something about bridging, I just say, ask them. So you might as well do it in one go. And also for international admissions, all the requirements are on the website, but also there what we require is a similar level to mechanical engineering bachelors from Delft. So if you're doing something in biomedical engineering or you have a motion sciences bachelor abroad, usually it's very difficult to get in because again, we require the equivalent of a mechanical engineering bachelor degree because we are a mechanical engineering master track. So that is about before your studies, how you might get in. I want to round off with saying a few things about where you might go after doing biomechanical design. And the answer there is, it's very broad. I won't say you can do pretty much anything, but mechanical engineering graduates are sought after in almost all industries. So a colleague of mine a few years back did some research on where our graduates end up. And again, they end up pretty much anywhere where you would expect other engineers. So you can have a good odds of getting a job at one of the big corporations if that's your thing. Don't work at the evil ones who are destroying the planet. That would be a waste. Also, a lot of people also end up at universities or research institutes. Again, like other engineers, some of our graduates decide after graduating that mechanical engineering is not for them, and they end up in consultancy or management or government institutions. And of course, a growing number of people are starting or joining small startups and spin-offs, sometimes in connection with the research that has been going on with their thesis projects and their supervisors, for instance, but also completely unrelated. Again, because you'll be specialized in biomechanical design, but you'll have all the skills people expect from a general mechanical engineer. So which specific companies then do people end up in? Again, it's a long list. I'm not even going to zoom in on this. You don't need to read them all. The only reason I put them all on the screen is to show you it's very, very, very broad. Even if you look at the titles our graduates have, it's anything from what you'd expect, biomedical engineer, mechanical engineer, product engineer, to simulation consultants, technical software engineers, business developers, business consultants. It's all over the place. And again, the thing that binds all these things, that is the common factor, is you'll graduate as a mechanical engineer with a specialization in biomechanical design, so with very, very good design skills and with up-to-date knowledge on some very popular technologies like compliant mechanisms, like 3D printing. So a good part of our graduates actually go do work in biomechanical design or in biomedical engineering, but also a large chunk step away from the bio part and use their design skills and their knowledge about all the technologies that are involved in biomechanical design to do different things. So that is what I had to say. In a minute, I'll open the Q&A and the chat and to see what questions remain that Eva wasn't able to handle yet or wants me to talk about. But that is it. And again, if you have questions about bridging, please ask them of the bridging coordinator, because it's the same for mechanical engineering across the board for all our tracks. Of course, there's some information on the website, which is outdated at the moment. Like I said, the table of the curriculum and the brochure will update those as soon as we can. But at the moment, they show the old curriculum. I am also available for questions. You can reach me via this address, so coordinator bmd3me@tudelft.nl. That address is also on the website. Feel free to ask me anything. But please do look at the website first. So that goes for international admissions, and it also goes for things like bridging. But again, bridging, I'll forward you to the other address. But all other things, if you've looked at the information and you still have questions, or after we've answered your questions today, tomorrow you wake up and you go, hey, wait a minute, I really want to know this. Do feel free to answer me, to email me, and I'll do my best to get back to you in a reasonable time. So I hope this was informative. I'm going to have a look at the questions. I'm going to have a look at the questions. That's what we're going to do now.